machine. So machine is the combination of different linkages where it is used for power transmission from one link to another link. Then we have studied a difference between machine and device. So it will see, it will say uh, when there is a combination of linkage and power is transferred from one link to another link, and which will help to reduce the human efforts, it is called as machine. Linkage should be there. Whenever there are linkages, then only machine come into picture. For example, a computer is also a machine. Even we can call it as a computer also a machine, because it will, computer is a machine. Electronic, we are calling it as electronic machine, which reduces human efforts like calculation, storing data, etc. So similarly, machine and device. So that is the basic difference. Mobile is called the device actually. So there is no linkages, even a stapler. So I have asked a question: what is machine and device? So some of the answer came something like device is very small, machine is large. So that may not be correct answer. Why? Because in case of stapler, if we'll take the example of stapler or punching machine, so its size is very small as compared to, we can say, that machine as far as size is concerned. So that is the difference. When different linkages will come into picture, or linkages are connected with each other, then we are calling it as a machine. And device is nothing but a simple device where linkages are not there. Example of machine is our lathe machine, drilling machine, all mechanical machines. Maybe stapler, even punching machine, even JCB is also machine where hydraulic links are connected with each other. So that is the machine. Then we have studied what does it mean by drawing. Drawing means what? That we have studied. Okay. So in as far as drawing is concerned, what is meant by drawing? Drawing is nothing but a pictorial view of any object is called as drawing. But what is the difference between this drawing and our mechanical drawing? In this drawing, technical specifications will come into picture. Unless and until there are no technical specification, this drawing don't have meaning. So dimensions should be there for the drawing. That is the important thing in this. What I am telling, dimension should be there. If there are no dimensions, that we cannot call it as a drawing. As simple as this. Suppose a civil engineer will draw a 2D plan of a particular home, and he will give to you, but it don't have any dimensions. Suppose, so it don't have meaning. As simple as this, we cannot say how much built up area, etc. What will be the cost? Because without dimension, there is nothing. So unless and until dimensions will not be there, this drawing will not play any important role. Okay. So after that, we have seen first title in this study of BIS conventions. So what is the long form of BIS? What is the long form of BIS? So first title is significance and importance of BIS conventions. Can anybody tell long form of BIS? BIS. Anybody, Balaji, please say. Ajit Gaikwad.
Bureau of Indian
Balaji.
Standard.
Of Indian Standard.
Whether my voice is audible to you?
Yes, sir.
Okay, clearly or something blur?
Sir, long form
Huh?
BIS, Bureau of Indian Standard.
Bureau of Indian Standards. Very good. That is the long form of BIS, something like WHO. So nowadays we are listening this WHO many times. So what was for? Stands for WHO, World Health Organization. So something standards, or we can say rules, are developed by WHO for, we can say, health related issue, health. But as far as drawing or mechanical components are concerned, So this BIS has implemented the standards in our drawing, machine drawing, or in mechanical engineering, we can say. Standards are implemented. Standards are implemented by this BIS in our, we can say, day-to-day life. So that is the meaning of significance and importance of BIS convention. In that, what was for BIS stands for Bureau of Indian Standards. Bureau of Indian Standards. So what is this? What is this? I have given example of pen. Pen. If suppose a pen, for my pen, suppose refill is over. So that example we have seen. Suppose refill is over. What we are doing generally? In general, if it is not use and throw pen, what we are doing? We are going to shop and we are purchasing a refill for that pen, and then we are just replacing the previous refill by new one, so that we can continue our this use of pen. Okay, simple like this. Significance and importance of BIS convention. What will be this? What we are doing? Simply replacement of the part in BIS convention. So standardization. In practical, suppose in assembly particular part gets worn out or damaged. What we are doing? What we are doing? We are just replacing that part. On which basis, or how we can say this particular part, replaced part, will be get automatic fit or gets fit into the assembly? On which basis we are saying? It is on the basis of standardization, because parts are manufactured in standard dimensions. So that is the important significance and importance of the BIS convention. Standardization. What is meant by standardization? Parts are manufactured in standard dimensions. That is the number one. It is called as standard dimensions. Number one. Then number two. What is that? Number two. Interchangeability. What does it mean by interchangeability? Interchangeability is nothing but once part is going to be a manufacture in standard dimension, it will get automatic fit, or we can say interchange. It can be interchanged easily because it is manufactured in standard dimensions. And what is this? Last one is reduction in efforts. Why reduction in efforts? Because our efforts will be reduced for new manufacturing. That is the importance. New manufacturing efforts will be reduced for new manufacturing. Okay, so this is the importance, we can say, or reduction in efforts. Or I will give an example. Maybe you are remembering. Suppose as an engineer, you want to purchase nut or bolt, or you can say nut and bolts. And if you will enter in a hardware shop, so how you are going to ask shopkeeper to give nut or bolt? Anybody? On which basis you are asking this? We have studied this. On which basis? Anybody is remembering? On which basis you will ask a shopkeeper to give nut and bolt? It is not in kilograms, no? 1 kg nut, 1 kilogram bolts. Huh?
MM.
In mm. It will be given. So it will be specified in standard dimensions like M10, M10, M, capital M, M10, M12, M14. These are the standard dimensions. What the way? Suppose you will enter any shop, you will ask sugar, 1 kg sugar. I want 1 kilogram sugar or 1.5 kg sugar, like that. It is in kilograms, but nut and bolt we cannot purchase in kilograms. Okay, standards are maintained. So how it will be? Suppose I want to purchase nut and bolt. So immediately shopkeeper will ask which nut, M10, M12, M6, whatever, or M30, whatever standard dimensions are there. So The guarantee of replacement of part in assembly is called as replacement. Guarantee of replacement of part in assembly is called as interchangeability. Means as the parts are manufactured in standard dimension, it will be replaced easily so that it will get reduced in efforts that we have seen. Then what we have seen, title block. So typical title block or title block of a sheet. So first orientation or first sheet is showing something like landscape or horizontal way. Another one is vertical, or it is also called as portrait way. Portrait. Okay. So what does it mean by title block? Title block. So if being an engineer, if someone will open the drawing, so immediately that person should come to know that what is the title of that drawing, what is the sheet number, what is the scale, what is the symbol or symbol denoting the method of projection or name of firm, and initials of drawn, checked and approval. That things means on a particular sheet, only drawing should not be there. Along with the drawing, these many things should be there. Which are they? First, there should be title of drawing. This drawing, suppose mechanical drawing, any engine casing, something like this. So that drawing should be there. Number one, title of the drawing, sheet number. Then sheet number means how many sheets we have used for the particular drawing. Scale, 1:1, maybe it is larger or it is smaller, whatever scale it should be there. Then symbol denoting the method of projection. So how many methods are there? Anybody can tell how many methods are there? Methods of projection. Let us discuss in this.
Methods of projection. Anybody can tell answer? Shubham, is it possible for you, Shubham Gandole? Shubham Gandole?
Yes, sir.
How many methods are there? Methods of
माहित नाही sir.
माहित नाही. In which class you were? Okay, Misal, how many methods of projections are there? 4. Will you tell which are they?
Don't know, sir.
Balaji Pise.
2, sir. First angle
How many?
and third angle.
Shubham, first angle and?
Third angle.
Okay. First angle and third angle. Very good. For anybody, is it possible to explain this? Is there anybody who can explain this? What is first angle and what is third angle? So first angle method, very simple. In graphics basics only you might have studied. What is this actually? First angle method of projections means we are imagining object is placed in first quadrant, and in third angle method of projection we are assuming object is placed in third quadrant. It is as simple as this definition, or we can say meaning of that. What is first angle method of projection? Object is placed in first quadrant. What is third angle? Object is placed in third quadrant. So one more difference. In first angle and third angle, front view is above the XY line and top view is below the XY line. On the other hand, opposite is the case in third. Top view is above the XY line and front view is below the XY line. Okay, likewise. So there may be certain questions may arise in your mind. Number one, why we are not using second angle and fourth angle method of projection? So that answer also I have given. What was that? Why we are not using second angle and fourth angle method of projection? In short, maybe this may be your technical interview question. Anybody can tell answer from you our why we are not using second angle and fourth angle method of projection. Only there are two methods. One is first angle method of projection and third angle. Who will give answer for this? Gaurav Karande. Gaurav.
Yes, sir.
Huh? Is it possible for you to give answer? First angle and third angle is there, but there is no such method called second angle method of projection and fourth angle method of projection. Basics of engineering graphics. Is it possible for you, Aniket Kapse or Kapse?
No.
No. Anil Dongre. Dongre. Okay. So what is happening in second angle and fourth angle method of projection? The views are overlapping each other. Means front view and top view will come in case of second angle method of projection. Both will come above the XY line. Means front view and top view will get overlap. On the other hand, in fourth angle method of projection, top view and front view will come below XY line. Both means it will get overlap. So it will be very difficult. The drawing will become very complex, or due to overlapping it will become complex to understand. That's why these two methods are not used. In short, being a mechanical engineer, we should be able to answer this question. Why second angle and fourth angle method of projection is not used in practical? Because front view and top view are getting overlapped in both cases. This is the answer. As simple as this. Both the views are get overlapped. That is the simple answer for this. Okay. Next. Then a typical title block. Maybe in engineering graphics you might have drawn, or you might have taken a Xerox copy of this. So similarly here also we are going to draw a typical title block. The dimensions are given. So same thing. Name of the firm or organization or company. So in our case we have written our college name. Then title of the drawing. So BIS convention. Maybe any part, camshaft top machine, any suppose camshaft top in vehicle, etc. It may come. Then name. Who has drawn, who has checked, who has approved. This also. Then sheet number, scale. Then your details will come into picture. Then next we have seen that standard drawing sheet sizes and layout recommended by BIS. Standard sheet sizes. How many standard sheet sizes are there? Thus many times we have discussed this thing also. How many standard sheet sizes are there? How many? 1, 2, 3, 4, 5, 6, 7. How many are there?
5.
5. Very good. 5 are there. Right from. So you can see. So one of the diagram. 5 are there. Right from A0. A0, A1, A2, A3 and A4. So total how many are there? 5 are there. So how to remember this? So this table will be asked for multiple choice question that we have seen many times. This question will be asked for your multiple choice questions. Total how many are there? 5. So out of this, so whatever printout pages we are using to take the printout of various documents, that is nothing but A4. So this large, smallest sheet is there, smallest sheet for printer. What the way we are drawing the drawing? It is A4. So that A4 sheet we have to remember. Size of A4. Size of A4 we have to remember. So what is that size? So that size is here. A4. This size. Sorry. A4. So this is the smallest sheet size. Out of that, we have to remember this sheet size of this A4 sheet. This A4 sheet we have to remember. A4 sheet. Okay. What is that A4 sheet size? A4 sheet size is nothing but 210 into 297. This is the sheet size we have to remember. Then which multiplication factor we have to take here, like that I have told? Which multiplication factor? The ratio of length to width is 1:1 root 2 root 2, like this. It is there 1:root 2. That's why once here I will write something 1:1 root 2. Then this 297 we have to take as it is for next sheet, as it is. Then multiply it by root 2. You will get next digit. Then this 420 as it is you have to take for next step, as it is. Then you have to multiply it by root 2. Then next 594 as it is you have to take, as it is. Okay. Then you have to multiply it by root 2. Then what you have to do? This 841 you have to take as it is, multiply it by root 2. You will get next digit. Likewise, such table you have to form. So out of this table, or once you will come to know this table, what you have to remember? Which is the largest sheet size out of this table? A question may arise. Which is the largest sheet size?
A0.
A0 is the largest one, and smallest one is A4.
4.
A4 is the smallest sheet size, and A0 is the largest sheet size. For multiple choice question, this table is very, very important. If you open university question paper, many more questions will come. Okay. Then we have seen conventional representation of engineering materials. So how different engineering materials, or which materials we are using, so how its conventional representation can be shown. So that thing is there here. Conventional representation of engineering material. This is the simple title of this. Okay. Conventional representation of engineering material. In that metals are there. Metals. Maybe first one is metal. So you can see first one is metal, another one is glass, then packaging and insulating material, liquid, wood, concrete. Like this it is there. Okay. So what is this? Only we have to draw one rectangular block. In that you have to show just a material. Maybe in your applied mechanics or maybe basic civil engineering. So one of the famous symbol you have seen like concrete. This concrete symbol came many more times in your basic civil engineering. Basic civil. Same symbol. Same symbols are there. Some other symbols. Metals. So in our mechanical engineering, this symbol will come many more time. Metal. Okay. So this again there are two types of metal: steel, cast iron, copper and its alloys, aluminum and its alloys. Only hatching line. Something we can say one directional hatching line. Only one hatching line. And if both side hatching line, if it is lead, zinc, tin or white metal, both side hatching line it will come. Then glass, symbol of glass, something like symmetrical symbol. If glass is having something like this symbol, it is called as this one rectangular block in which glass is there. Then porcelain, stoneware, marble, slate, etc. It is called packaging and insulating material. So in your heat transfer, one subject you are going to learn in the third year HMT. heat and mass transfer. In that you are come to know that this insulating and packaging material. Then water, liquid, etc. So in chemistry, many more time you might have uh, shown this something like this called water, oil, petrol, kerosene, etc. How this can be shown? Okay. And last symbol is wood or plywood. So how it can be shown? Simple, this symbol. So just you can see the symbols where how it can be shown. Okay. So this symbol is for wood. Something like this. Symbol of wood. Okay, then we have seen types of gears. Okay, conventional representation of gears. So in basic mechanical engineering, you have seen the application, how it's working, where actually it is used, and what are the different types of gears. But as far as machine drawing subject is concerned, here we are supposed to study types of gears only for its drawing, how it can be shown. That is only important in our case. So actually this use of this gears, etc., everything you have studied in basic mechanical engineering. We are interested only in this. We are interested only in this. What is this conventional representation of gears? How gears are shown? We are interested in only this diagram, nothing else. So remaining diagrams, whatever diagrams are there, that diagrams are only for your information. I have kept here. Only we are interested here only. I will do star mark something. Okay. Here only. So what is spur gear? Can anybody explain what is spur gear? If I will. So types of gears. First, what are the different types of gears? First is spur gear. Another one is bevel gear. Then worm and worm bevel. So what is first? Sorry. What is spur gear? Can anybody tell answer? What is spur gear? So explain spur gear. So what do you know about spur gear? Anybody? Kunal Shetty.
Yes, sir.
Will you define what is spur gear? Or will you explain what do you know about spur gear? One answer came to teeth are parallel to the shaft. That is also correct. Any other answer? Gaurav Karande has given answer. Teeth are parallel to the shaft. Axis is parallel to each other. Okay. Instead of axis, we should say shafts are parallel. When shafts are parallel to each other, then this type of gears are used. Okay. So what is this? Number one, conventional representation of gear. So few things I will tell. As far as these two shafts are parallel, this is also correct answer. Shubham has given. So what is this? When teeth are parallel to the shaft axis. So in general, 50% answer is given by most of the student. What is this? Spur gear. Teeth are parallel, but to whom? That is very important. Teeth are parallel, so that is not complete answer. What is this conventional representation in spur gear? What is spur gear? When teeth are parallel to the shaft axis, it is called as spur gear, and it is used to join two parallel shaft. That is the simple answer. Okay, for spur gear. And in this, what we have to remember? So hub you have to remember. Where is that hub? Maybe this much is hub. Okay, it is called as hub. HUB. Hyper hub is used. Hub. I will write here hub. HUB. Why for it is used? hub, this structure. Where is this actually? So this hub is here, something called, we can see here, hub. Why for it is used? Hub to fix the shaft, to fix the opposite, to fix the shaft on the shaft. Hub is used. Okay, what is bevel gear? So there are two angles in bevel gear. Which are they? One is beveling angle, and another one is beveling angle of bevel gear is how much? So this sentence I have told many times. Beveling angle of bevel gear is option number 130, 45, 60, 90. Which will be correct answer?
45.
45 is the correct answer. What is beveling angle? Beveling angle is nothing but the angle at which teeths of gear are inclined to the shaft axis. Means so whatever these teeths are there, so these teeth, here it is shown, these teeths. Just keep in mind, these teeths are inclined to the shaft axis at angle of 45. At an angle of 45. So you can remember this 45. That's why it is called, same is here, same angle is here also. So what is this 45 degree? Beveling angle of bevel gear is 45 degree. Means teeths of gear are inclined at 45 degree to the axis. And what is 90 degree? What is the significance of 90 degree angle? What is the significance of 90 degree angle in case of bevel gear? Anybody? 90 degree or perpendicular?
Power.
Correct. Who is correct? Who is there?
Gorakundvir.
Very good, Gorak. So what is 90 degree or perpendicular? Bevel gears are used to transfer power through 90 degree. That is the importance. So two angles are there in this. Two angles are important in case of this. One is 45 degree, another one is 90 degree. Another one is 90 degree. So what is this? 45 degree. The beveling angle of bevel gear is 45 degree. Means teeths of gears are inclined at 45 degree to the axis. And what is 90 degree or perpendicular? Bevel gears are used to transfer power through 90 degree. Then worm wheel. So as far as worm wheel and spur gear is concerned, here is the difference. So this much. So it is flat one. These teeths are flat one, and here these teeths are something like concave shape. That is the main difference, nothing else. Otherwise, this gear is similarly as like spur gear, only concave shape. So this structure is there. This how teeths are there. So you can see how these teeths are there, concave shape. That's why while showing the front view of worm wheel, that concave shape is shown. Okay. Then worm. Then we have seen what is worm. Okay. So worm is nothing but it is a simple. It is called something like this. So which thing is missing in this worm? So that we have seen.
Hub.
Hub is missing. Why? So important thing related to this you are remembering correctly. Hub is missing. Hub missing. I will write here. Hub is missing. Why it is missing? Can anybody tell? What is the use of?
Sir, because in spur gear, gear is mounted on shaft, but in worm wheel itself is a shaft.
Very nice. 100%. Gaurav is there or who?
Yes, sir, Gaurav currently.
Very good. 100% correct answer. Why? Because in all other types of gears, maybe worm wheel, bevel gear, spur gear, etc. In all cases, this Gear is mounted on the shaft. Shaft is different, gear is different. In spur gear, in bevel gear, maybe in worm fill, or it is also called as worm gear. In all cases, it is mounted on the shaft. So you can see here how this hub is shown. So this hub means something like how it is shown here, hub. How it is shown here, hub. So you can see. So, but in case of worm, this hub is missing because it is itself is a gear, and it is mounted on another shaft. Okay, that's why in worm hub is missing. Then we have seen gear assemblies. Then we have seen gear assemblies. So how many gear assemblies we have seen? So this type of question will be asked for 5 to maybe up to 8 mark. Draw BIS convention of maybe bevel gear assembly, spur gear assembly, maybe other likewise. Okay. So what is this? What is this spur gear assembly? So what is assembly? So only one individual gear cannot form a assembly. It is as simple as this. So when minimum two gears should come into contact into each other. Minimum two, maximum more than two, no problem. So what is gear assembly? When two or more gears will come into contact with each other, they will form a assembly. Okay. First one is spur gear assembly. So two spur gear. So actually this diagram is very simple, but that structure of gear etc. is made little difficult. So whatever this line is there, it should pass something like this. Okay, this line will pass. This line will pass something like this. Okay, so what is this spur gear assembly? What is this actually? So what care we have to take whenever there are two gears? So whatever pitch line or pitch circles are there, that pitch line or pitch circle should touch each other at a one point. So that care we have to take while drawing this diagram. What will happen? Suppose if these pitch circles or pitch line will remain away from each other, it means power is not transmitted. Or on the other hand, means suppose in one case it should not happen something like this. Here there is one, I will draw maybe one pitch circle something like this, and another one is something like this. Means there is gap. It should not happen something like this. Why? Because it means power will not be transmitted in that case. So on the other hand, both these pitch circles should not be something like this also. Like this. Means these are intersecting each other. If they are going to intersect each other, it means jamming of gear will happen and power will not get transfer. Then this is bevel gear assembly. So what is that? What the way we have seen? Perpendicular. What is this perpendicular? Perpendicular is nothing but bevel gears are used to transfer power through 90-degree, or it is used to transfer power in perpendicular direction. So if we'll see in all cases power will be transferred through 90-degree or perpendicular to each other. So in all cases you can see shaft top side bevel gear and bottom side bevel gear. In all cases power is transferred through 90-degree. So you can see this how it is transferred in all cases. And that is the main application of bevel gear. Okay. So this is also same is here. So whatever this vertical gear is there, this much vertical, and horizontal gear, maybe something like this horizontal and vertical. So pitch line should touch at one point only. This is one point. 1 point, like this pitch line should touch at 1 point only. Then we have seen worm gear assembly or worm and worm wheel. So what was application we have seen for worm gear assembly? Is it possible to see the actual application or animation of this? Are you able to see? Are you able to see? Yes or no? Worm gear assembly. How it works?
स्पीड रिड्यूस
Huh?
स्पीड रिड्यूस करण्यासाठी
काय झालं?
स्पीड रिड्यूस करण्यासाठी
Speed reduction. Very good. Application you have told. Very good. But is it possible to see this animation for you? So those who have not understood by theoretically only, so I have kept here little animation. So how speed reduction is happening in this worm gear assembly? Is it possible for you to tell for anybody? So top side is worm and bottom side is worm wheel, or we can say worm gear. How speed reduction is happening in this worm gear assembly? How speed reduction is happening? Can anybody tell? For one rotation of worm, how much advance is happening in case of worm wheel? So top side, whatever worm is there, worm, top side this worm. Suppose one rotation, this will take one rotation, one complete rotation. So at that case, this will rotate. Only here I will write one rotation, one R. One rotation. This worm wheel will advance through one teeth, not one rotation. One teeth, like this. So what I have written? If worm will rotate through one complete rotation, then worm wheel will advance through only one teeth. That's why in this, suppose this is having 60 teeth. So this worm wheel is having 60 teeth. Suppose 60. This is having 60 teeth. 60 teeth. 60 teeth. Mean one complete rotation of worm wheel. How many rotation of worm will take place? If this will rotate through 60, or we can say one rotation. If this will complete one rotation. So how many rotation it will take? Worm? Only one rotation of this worm wheel. And here this worm will take 60 rotation. So that is the meaning of this. Worm wheel is used, or we can say it is used to get high speed reduction ratio. So this is the diagram. Again, if possible, you can see, you can modify it to the simple. If possible, you can modify it to simpler one also. So whatever diagram is shown, it is with the hub, etc. It will be a little difficult. Then rack and pinion. Fourth gear assembly we have seen. What is the application we have seen? Rack and pinion, or what will be the application of this rack and pinion? Rack and pinion application. So looking to the animation also, you can see rack and pinion. Rotary into translatory. Very good. Correct. Means whatever this rotary motion is there, it will be converted into like this rotary. It is as simple as this, or you can see it is rotated in this way. It is rotated in this way, and here, if possible, you can see it is something like this. Okay, rotary. It is used in steering mechanism of automobile. That application also you can remember. Steering, I will show at the end. what is this application. Okay, then after gears, so summary of gear and gear assembly. Four types of gears we have seen. One is spur, bevel, worm wheel, and worm. These are the four types for which we have seen what is its BIS convention. Four assemblies we have seen. One is spur gear assembly, bevel gear assembly, worm and worm wheel, and rack and pinion. These four assemblies. Then conventional representation of machine components. Conventional representation of machine components. In that, now we are going to see one by one now. Knurling. So spelling of knurling, you and I have told. What is this knurling? What is knurling? Technical interview. What is knurling? Knurling is nothing but it is used for getting firm grip. Firm means like this. Fix, we can say fix. Firm. Firm grip. If we want to have a firm grip on the component, it is used for that. If structure is provided something like this, if structure is provided something like this, straight, then it is called as straight knurling. If it is something like this, then it is called as something called as a diamond knurling. So knurling is nothing but the structure provided for the component for having firm grip. So it is of two types. One is straight, another one is diamond. So what is square on shaft? Square on shaft to avoid slippage of the mounting on the shaft. So avoid slippage. So this you have to remember, to avoid slippage of component. Slippage. Avoid slippage of component. That is the important task, or we can say important thing in this. Okay. Then holes on circular pitch. A particular component is having these many holes, number of holes. So you can count. Next fourth type is holes on circular pitch. What is this holes on circular pitch? A particular component is having these many holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what you will do in actual, you can have only one hole. So one hole is shown here, and remaining can be shown by dotted line, or we can say center line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. So number of holes can be shown by only center line, not necessary to show all the holes. Then bearing. Bearing also we have seen. What is the definition of bearing? Bearing is a mechanical element. Which thing you have to remember as far as bearing is concerned? I have told yesterday also. So which thing you have to remember as far as bearing is used? Why for bearing is used in mechanical application? Bearing. Why? Support to. Correct. Gorak has given correct answer. What is this bearing? Why for bearing is used to give support to shaft. As simple as this. Then having rotational friction, minimize friction, etc. These are the secondary purposes. First purpose of the bearing in assembly is to give support to the shaft. Question may arise, why it is necessary to give support to the shaft? Why? Because I have told also definition of shaft. Shaft is nothing but a rotating mechanical element. Rotating is very important. Rotating mechanical element which is used to transfer power. That is the shaft. So as shaft is going to be a continuously rotating element, is to be continuously in a rotating position, it is very difficult to give support because it is rotating. That's why these bearings are used to give support to the shaft. These bearings are used to give support to the shaft. Okay. Then we have seen threads. So here in BIS convention, threads So what the things I was telling always, external thread and internal thread. Nuts are having internal thread, bolts are having external thread. So bolt, so as far as that symbol is concerned, so here it is. So now I will not go in that depth. Okay. So this is bolt. Now you should be able to identify which is nut, sorry, which is nut and which is bolt, like this, which is nut and which is bolt. So bolts are having external threads, external circle is complete. So that thing you have to remember, nut and bolt. And nuts are having internal thread, internal circle is complete. So bolts are having external threads, external circle is complete, like this symbol. Okay. And automatically, as external is complete, internal will come incomplete. On the other hand, on the other thing, nuts are having internal thread, internal circle is complete, and external is incomplete, like this you can remember. Okay. Then we have seen spline, the shaft which is having splines. So if you say this view, splines means we can say serrations. So this view of shaft you are going to see from this side of the shaft, which is that. So this one, this. So this is the view of shaft. So what is where we are using spline the shaft? So structure is something like this, spline the shaft. Where we are using spline the shaft, I have given an example also. When we are using spline the shaft, anybody spline the shaft, when we have to use. So I will show. Actually, it is not there in this. Spline the shaft when. So you might not be remembering when we have to use spline the shaft, when we want, or if possible, when we want to have change in length, when we want to have change in length, or our assembly should allow change in length. In that case, these planned shafts are used. Interrupted views. So this views in maybe in your mechanics of material. This is might be known to you. This mechanics of material. So whenever we want to have something interrupted view, this is used. Interrupted views means total shaft is not shown, but its interrupted views is shown. Then lip spring, semi-elliptical lip spring, etc. Lip spring. Many more types are there for lip spring. In the Marathi, we are saying it as a pata. In our assembly, or we can say in vehicles, it is said as, in Marathi we are saying it as a pata. Okay. So again, different types are there. With eyes, without eyes, with center band. What is center band? Center band is nothing. Eyes means what? Where it is mounted with the chassis of vehicle. Mounted with chassis of vehicle. Okay, eyes. What is this center band? Is actually it is not shown, but it is something like this. This center band. This center band. Okay. Then cylindrical compression spring. So where is this cylindrical compression spring? It is here. Cylindrical compression spring. Where it is used, or why it is used? Cylindrical compression spring for in shock absorbers to take compression load. It is used. It is used to take compression load on the component. It is for used and tension load. So we can say shock absorbers in two-wheeler. It is even our pen. In case of pen also, the cylindrical compression springs are there. Tension spring. So you can see here weightlifting machine, bicycle stand, or any vehicle stand. This is spiral spring. Toys. So whatever small toys are there in that, all toys, we can say in in all toys. This twice is the famous application of spiral spring. This is the discus spring. Another one is discus spring. Okay. Then ratchet and pawl. What is the application of ratchet and pawl? Are you remembering or looking to the diagram? Ratchet and pawl. Let us revise our or wash our brain. What we have studied. Ratchet and pawl. Anybody? Kunal Shetty. Ratchet and pawl. Look at the diagram. See the diagram and Kunal Shetty.
क्रेन मध्ये असते.
कुठं?
Yes sir. क्रेन मध्ये.
Very good. One famous application of ratchet and pawl is crane. Again, I have given 3-4 examples for this. Admile, ratchet and pawl. No. Rahul Chaudhary. One is the crane, especially engine crane. When that engine suppose is unable to lift a particular, we can say, bucket. So if it is unable to lift, that bucket will fall into the well. Then in that case, accident should not happen. In that case, ratchet and pawl is used. If at all engine will fail. Any other example? Sujit Mane. Example. Bicycle sprocket. Suhash Nashte is given example of bicycle. Very good. So where actually it is used in bicycle, when we are moving paddle in forward direction, engagement will happen and power will get transfer and that bicycle will move in forward direction. On the other hand, if at all we are going to move paddle in reverse direction, disengagement will happen and power will not get transfer. Okay. How? Otherwise, what will happen? In both cases, engagement will be there. What will happen? Once we are going to move paddle in forward direction, bicycle will move in forward. At the same time, at all we are going to move in backward direction, bicycle will move in backward direction as well. So in one case, there should be a disengagement. One more example I have given. Anybody is remembering? Prathamesh Patil. Prathamesh Patil, Mayur Shalke.
No idea.
No idea.
Sir, Jax.
Jack. Which one? Which Jack? So starting of engine, you might be remembering how we are starting the engine with the help of handle. There is one handle, no? So what we are doing generally, there is one slot to the starting shaft of engine. We are fixing it. Once we are going, have you seen the starting of engine with the help of handle? How engine is started? Have you seen how engine is started with the help of handle? Maybe engines. So what is happening or what is the working principle in that? Actually, once we are moving that handle of engine in forward direction, engagement is happening. At the same time, once we are going to move in backward direction, disengagement is happening. Why this mechanism is used? Because once engine is going to be a start, we should be able to remove that handle. Otherwise, handle will move along with the engine and sometimes we may move along with the engine. So to avoid the accident, for that purpose, this such type of ratchet and pawl mechanism is used in case of. Okay, so this we have seen elementary welding symbols. Actually, what is this elementary welding symbol? Only symbols are important only. So this column, second column, is not that way important. Second column is not, we can say, that way important. It is for just our information. What we have to remember? We have to remember symbol. But weld, between two plates. So butt weld, two plates are kept in front of each other. BOTT, butt means in front of each other. So symbol is something like this. Then square butt weld, symbol is like this. Phi butt weld, phi symbol. Then single bevel butt weld, this symbol. Then single phi butt weld. Then only symbols. Now I will not read it, it is just like a list. Then these symbols are important as far as multiple choice is concerned. These symbols are very important. Which are they? First one is single U, backing run, fillet weld. Fillet weld, you have to remember this symbol. Then plug weld. Slots will be made into the plate and that slots will be filled. Then spot weld means spots are given on the plates, different spot. Okay. Last one is seam weld. So this symbol only you have to remember. There is nothing to tell about this. Then last part from this chapter is types of section. Last part from this is types of section. So mainly there are these 6 types. Which are they? First one is full, half, offset. These first 3 and last 3 partial section, revolved section and removed section. These 3 sections. So mainly first 3 sections, if you'll see carefully, first 3 sections, these 3 and last these 3. First 3. So it may not be possible. First 3, on which basis these sections are there? Full, half and offset. Can anybody is remembering? Full section, half and offset. Anybody is remembering? This way of seeing in depth. Full, half, offset. Or I will say why sections of object is necessary to take engineering graphics orthographic projection chapter. Why it is necessary to take section of object? Or you might have seen the chapter called as sections of solids. Why we have to take section of object? Anybody is having answer to this? Why we should take section of object? Rahul Chaudhary, Rahul Gaikwad.
Yes, sir.
Why we have to take section? Chaudhary? No? Actually, sections of objects are taken to view internal details of the object. Section of object is taken to view internal details of the object. That thing you have to remember. Then these first 3 types are depending upon symmetry of the object. First 3 types. Which are the first 3? Full, half, offset. Means if these are the depending upon symmetry. In full section. Why it is called full section? Because in full section object is symmetrical about only one axis. Object is symmetrical about only one axis. You have to remember. Then why the name full is given? Because cutting plane is passing through whole object or full object. That's why it is called as full section. Number 1. First thing you have to remember, when object is symmetrical about one axis, when object is symmetrical about one axis, full section of object is taken. And other thing is what? Why it is called full section? Because cutting plane is passing through whole object or full object. Next, what we have to remember? How much part of the object is imagined to be removed in this case? How much part of the object is imagined to be removed in this case?
Half part.
Kunal.
Half part, sir.
Half. Very good. Half is the answer. Means which part? So in sections of solids you might have studied this. So this much half part is imagined to be removed. the object between observer. Now here I don't have space. From this direction observer is observing, so object between uh, this actual object and observer is imagined to be removed, or we can say it is retained as it is in between object, then view is taken. So which things you are going to remember as far as full section is concerned? Object is symmetrical about one axis and half part is removed. Then half section. So as far as symmetry is concerned, in half section object is symmetrical about both the axis. Object is symmetrical about both the axis, and how much part is imagined to be removed in half section?
1/4.
1/4 or quarter. 1/4 or quarter, that is the correct answer. 1/4 or quarter. Okay. Then offset section. Offset section. What is offset section? So if you see this top view of this object, so this, is it symmetrical about one axis or two axis? This top view of object one axis. If it is symmetrical about one axis, why we should not take its full section? Is it possible to take full section of this object? Full section. So working principle of this offset section is what? When internal details of objects are not lying on single cutting plane. If at all I am going to take section of object in this way, these holes will remain apart, or it will not come on the cutting plane. That's why it is necessary to rotate the cutting plane. That's why offset section of the object is taken. It is as simple as this. That's why it is offset. So here in this case we cannot imagine how much part of the object is imagined to be removed. So in short, I will take quick recap. Full section, object is symmetrical about one axis, half part is imagined to be removed. Half section, object is symmetrical about both axes, 1/4 or quarter part is imagined to be removed. Offset section, when internal details of objects are not lying on a single cutting plane, then offset section of the object is taken, and here we cannot predict how much part of the object is removed. Then partial, broken or local section. Three names are there for this: partial section, broken section or local section. Three names are there for this. Okay, so what is this? In assembly, when we want to highlight a particular part, in that case this partial section of the object is taken. Revolved section. So here there is one angle. Why? If long object, so two things you have to remember. When object is very long object, this type of section is taken for long objects, and another one is 90 degree. You have to remember 90 degree. What is 90 degree? Whatever cross section of object is there, it is rotated through 90 degree. And what is removed section? Section is taken at one place. And it is shown at the other place. Section of the object is taken at one place and it is shown in other place. That's why it is called removed section. Okay, this was the last part. Maybe I will take quick recap. What is this partial section? Broken or local? Partial, local or broken, to highlight particular part in assembly. So here, so which type of key is this? So we have seen in pre-hand sketches types of key. In that one key is there something like this. So which is this key? Maybe something like this. Which type of key? Semicircular key. Huh? Anybody is remembering this name? Name of this key? Let us see. Let us see. Imagination. Which type of key is this? Saddle, sunk, partial, wood rough. Which type of is this? Kunal Shetty.
Yes, sir.
Which type of key is this? Actually, there is one shaft and key. So, which is the type of this key? So, see the PPT carefully. Whatever I have sent yesterday. So, this is the type of wood rough key. So that you have to remember. Wood rough key. Revolved section. It is used for long objects and section is rotated through 90 degree. Removed section. Section is taken at one place. It is shown at other place. So a little animation you can see. So actually it is the example of mainly it is shown for spur gear assembly. When spur gears are mounted on two shafts. When spur gears are mounted on two shafts, it will rotate in opposite direction. Likewise, for that purpose it is shown. And another one, this application is something like there is one machine called as press tool machine to manufacture different parts. For that purpose, this machine is used. So this one is also one of the application of this. So